So here we are. Basically the same thing. You're pulling current through the resistor bank. I got it down to one resistor because this is a higher power resistor, so that helps space-wise going through the Hall effect sensor. And now we have two comparators here, one for each tail light, a left and a right. For right now, they're both running off the same output from the Hall effect sensor. In the end result, there will be a Hall effect sensor for the left and for the right. But for test purposes, they both operate off the same sensor. The difference here, now that we have 5 volts out, yes, we're switching the fan still just for fun at this point, but we're using the output from those comparators to drive these LEDs, one for the left and the other for the right tail light, and they're on the switches now, so we can simulate turning it off, aka the tail light being out. And then we also are monitoring the brake light switch, which is now switch 1 being on. So when this is on, the brakes, you're pushing the pedal essentially, and that will signify here that you're pushing the pedal with that yellow LED. And using the LEDs and resistors, it's easy enough to just drop the voltage to a safe logic level for the Raspberry Pi, which is 3.3 volts, but anywhere in the 2 volt range is good enough for a high. So you can see on the voltmeter here, and the green wire is one tail light and the orange wire is the other tail light, and so we're reading both 0 there, meaning the tail lights are out, and then 0 here for whether or not you're pushing the brakes. So if you're not pushing the brakes, then the other two readings don't really matter because you're not pushing the brakes. But also we have another switch here, and this basically turns the LEDs on, and it simulates like running lights. So your lights are going to be on to some degree, even if you're not pushing the brakes. And when you do push the brakes using the other switch, you see they light up brighter, which is essentially the same thing that happens in a car. You're driving, your lights are on, you hit the brake, light up lighter. So you can see here when you do hit the brake, the yellow LED comes on saying, hey, you're hitting the brakes, you're hitting the brakes. And you can see here on the voltmeter that you'll have a high. So yes, we're hitting the brakes. No, we're not hitting the brakes. Yes, we're hitting the brakes. So then obviously, like I said, these are the two tail lights, left and right, that are both driven by the comparators. We can switch that one off to simulate a tail light being out, and we can switch that one off, or vice versa. It doesn't really matter. But you can see here that we've got 0 volts for the one that's out, and you've got 2 volts for the one that's on. So test bench wise, we're all set to send logic to a Raspberry Pi and show yes, the tail lights are on. And then obviously we can switch off the quote-unquote running light switch, and it doesn't really change anything because the tail brake pedal wire is obviously just in this case it's a diode, which is a lot less resistance than this 1K. So even if the running lights are on, that's going through the 1K, and then as soon as we switch to the diode, obviously most of the current goes through there. It's important to use the diode because before, even with the running lights on, on switch 8 here, you would get a little current coming back through the voltage divider to basically these simple logic circuits, and you would have about just under a volt, which would still be okay for the Raspberry Pi, but it was kind of on the threshold. So instead of using a piece of wire, I put a diode to make sure that no current flows backwards to this board. So we're going to start working on the Raspberry Pi, and the logic levels should be all good.